Okay, so ax squared plus bx plus c. This is called a quadratic equation, right? It's called quadratic expression.
Same thing. Oh, it's the equation with the equal sign.
Yeah. So if you have ax squared plus bx plus c is equal to 0 makes a quadratic equation. Okay. Now, let me ask you a question. Does quadratic equation always have an answer? So,
no.
What about this? What about ax plus b is equal to 0? This is a linear equation. Does this always have a solution?
No.
Yes. It's this. It's always minus b over a. What about this? The answer is no. Okay, and the general answer to ax squared plus bx plus c, we can show is this. Okay, which is called quadratic formula.
Why is it called quadratic?
So John's asking, why is it called a quadratic? The other thing that we know is called something quad is in geometry, right? Quadrilateral. Okay. So look, let's say you have a rectangle, and let's say each rectangle is a representation of length. So let's say I can let this be, for example, 2x plus 1, right? Let me actually even make it more general. Why don't I say ax plus b? And let me call this cx plus d. What happens? What's the area of this?
ax plus b times c.
Right. Ax plus b times by cx plus d. What happens if I expand this?
acx squared plus
you get a quadratic. Okay, it's called a quadratic because to express the equivalent of algebra equivalent of that is usually a two-dimensional quadratic figure. Okay, so some of you already seen this. Who here knows how to derive that? What was the idea? I'm not even gonna ask you how to derive it right now. How, like what process do you use to derive it? Okay, how do you go from here to here?